Oh, so welcome. Thank you for coming to my talk. For those who don't know, I'm Hazel Bradshaw, and I'm actually doing a PhD looking at serious games. So my research is in different things like flow theory and skill performance, using that for game design for educational purposes. So what I want to talk about today is one of the projects that I'm currently working on, which is, as it's titled here, Computer Games as Novel Medium Transfer, Knowledge Transfer. So I'm working with some guys down at Landcare Research, and this is all about looking at management of ecosystems, and mainly with the problem in New Zealand is possums. Thank you. So some of the context behind the research that, then I'll talk about the game. So in industry context for Landcare Research, they have to come up with effective pest control methods. And they have various different technologies, such as like doing aerial drops with helicopters, sending people in trapping. They've got funding obligations that they have to get through the government funding. They have a lot of strategies that they have to implement. And one of the key parts is they have to get public participation. So when it comes down to something like public participation, they kind of came to me to look at kind of novel ways of doing that. They have several research aims that they have to meet at Landcare. So they've got to reduce costs of aerial control and ground control when looking at managing possums. They've got to look at reducing the impact that these controls have, because you get a thing called bykill. So you get things, it can actually, you put traps down, you can actually get trap animals that you don't want to be trapping. So you can get things such as bykill of deer, and you can also have an impact on the bird populations as well. And then there's the research area 3, which is the increasing community participation. So this is where I come in. This is the kind of work that my work fits into this side of things with them. So they're working with the public. They have case studies that they work with groups of people around New Zealand, where they go and do research about what their implications of their possum control is having. And then it's a way of kind of looking at how to best inform the participants of these kind of groups. So they came to me for computer games. So this is pest control for biodiversity. This is the problem that I am tackling. It's a complex problem, as you can see. There's a lot of interaction goes on all through all of these types of things. And what we have was given as a basis of the computer game is a mathematical model which sort of links all these types of things together through a simulation. And then we kind of have the job of untangling that and putting that into a computer game that people can actually use, that is fun and engaging and actually teaches all about this complex problem. So we're looking at the interactions, the fact we've got restricted resources. You only get a small budget with this kind of control. You've got multiple stakeholders, so not only have you got the scientists, but you've got the communities, you've got the animal health board, you've got the farmers, you've got hunters, you've got all these types of people who are interested in this problem and who have different and often sometimes conflicting views. So the wicked problem that we have is finding the strategic technologies for managing not just the pests, but managing the people. So we want to get scientific knowledge transfer. We want to communicate the complexity of these types of problems. We want to get the communities engaged with these kind of quite scientific problems at times. And we need to get people to accept that there is some compromise in these. So at the moment, this is how Landcare and a lot of the research on this area is actually presented to the public. So you've got a lot of like really intense papers, which is fine for kind of guys like you. But when you take it out to someone who lives on the West Coast, and they're a farmer and they just spend their time looking after their animals and that kind of thing, they don't want to be reading this. It's not like they nip home and go, oh, I'll just read a research paper. So how do we get this to those people in a way that is kind of engaging? So this is where the little possum game comes in. So at the moment, it doesn't have a name. It's called the Possum Management Computer Game, which is rather dull. So we're still looking for interesting and exciting names. So if anyone has any ideas at the end of this of what to call this game, then that'd be great. So my rationale, I spent time working with Landcare right from the initials of sitting down and actually going through what the problem was and how we can actually find an approach to this. So the rationale that we presented was that it's a dialogue for engagement with the problem, scientific knowledge transfer, and use of novel media. So we're trying to look at the ways of getting the technology. Everyone's there out with a smartphone and an iPad and a computer and all that kind of thing. It's like, how do we get that group and how do we engage this problem with them? And find innovative ways to actually transfer research and implement research findings. So this isn't a one-way thing. It's hopefully a dynamic process where we can get information back from the people who play the games. So this comes into where I start with my research. So the first thing I do when I look at trying to create a serious game is I start looking at the motivational drivers of people. So we've got two types of motivation, intrinsic and extrinsic motivation. And what I've got to find with this is that the intrinsic motivation, so the motivation that you have within yourself that you will do something for the sake of doing it, not just because you've been told to do it, is that to maintain and restore the ecosystem based on biodiversity conservation. The research showed that those two things between science and the public were matched. It gets a little more complicated when you start talking about extrinsic motivation. So an extrinsic motivation is something you're motivated to do. So you're motivated to go to work because you get paid, because then once you get paid, you can go and do something with that money, so buy a house, go on holiday. So the scientists, they want to control the possums, possum populations, over time and in a spatial environment. And they want to promote understanding of how complex it is this problem is and how aware people need to be. The fact that there are at least 10 times more possums than there are sheep. And it's amazing, in 1 hectare you can have 20 possums living quite happily. And then they often little babies, and that's thousands and thousands and thousands of possums. The extrinsic motivations for the public, they want bird recovery, they want tree recovery. They want to be in with this whole New Zealand 100% pure kind of green and eco way of looking at things, and they want to preserve the game species as well. This kind of has crossovers when you start getting people who, to kill possums, you have to actually go out and you have to really trap them, and you have to use poisons, and then that's where it gets a little bit to gets to be a bit of a touchy subject. So the educational purpose, and the next part, the way I approach a research project like this, is to define a learning outcome. So the learning outcome is what we're actually trying to gain as an understanding of what we're trying to do with our project to get the people to understand. So realistic appreciation for a complex problem. And then the one I'm designing the game on, which is the learning objective, is to maintain and restore the ecosystem of the New Zealand forests, which is the intrinsic motivation. So we design the game based on that, and everything we put into the game has to feed back into seeing that learning objective come about. So then we have two objective tasks: monitor environment and manage environment. So the research purpose for all of this type of thing, and this down this side is my simplified thesis, let's put it like that. That's the kind of diagram of how I get from complex problem to metrics data, and so how that feeds through. So at some point that'll turn into a thesis, but if I could submit that now, I'd be very happy. So the reason for using kind of computer games, it's because they can provide context-based learning. So you can take this complex problem and think back to that slide with all the research papers, and you can put those in an environment where people can look at something and actually see what happens, the cause and effect, so you get the contextual relationship. The way I do it also implies that you've got a systematic approach, that you can measure every step of the way what you're doing. So you can look for your learning outcome and you can track it backwards through the system. So I'm not just taking a learning outcome or a problem from somewhere and coming out the other end and going, oh, well, I've made you a game. We can actually track that system through, which is really good for getting funding on things like this. Because a lot of the funding comes from government departments, Department of Conservation, a lot of it comes from the Ministry of the Environment. So we kind of actually need to be able to have a critical approach and say back to them that we can actually track the learning. It's cost effective as well. So that's a very attractive way of dealing with this when you're looking at funding bodies, is that you make what you're doing cost effective. So you're implementing design with educational impact, but you're doing with it within a system that can be measured. And therefore, we're not kind of going, right, we need another 100,000 or another. We're doing this on a really tiny budget. One of the other research purposes of this is that once I've gone through this, that it's a generalizable approach. Because I'm using flow theory, so that's Csikszentmihalyi's theory on optimal experience, that is a universal-wide theory that applies across nationalities. So we can embed that into these games. Then we've got a chance of kind of looking at that as more generalizable. And it doesn't matter which way you put this approach, if it's 2D, 3D, it doesn't matter what type of game, flash game, it doesn't matter. It's about the design behind it. Okay, so going back again to where we started with the game, we were given a science simulation that was created by my research colleague at Lancair Penn Holland. And she took all that research, all the data that you've been collecting on possum numbers and deaths and traps and poisons and all that, and she created a mathematical model which was turned into a science simulation that we can play through. This science simulation provides a spatial environment. It has trees, it has possums. Male possums are blue, female possums are red. You can have traps, you can have baits, you can just see this on an environment, so you can actually see what's happening in space. You can put in helicopters, you can put in contractors. The contractors react to the terrain, so if it's really steep, it'll take longer, and so on. And they'll sit down and have a bacon sandwich, and you can see how long it takes them to get somewhere. And we'll have different types of contractors some are slightly better than other contractors, and so on. And they all cost more or less. And we can put in all the equipment costs as well. So what we have for the pest management at this point is we have the simulation on one side, which is the expert user. So that's the one that the scientists are going to be using. And they can plot out what they want to do on this space, and they can do all the scientific data. And then there's the general public. And that's my domain, and that's the people that I try and look after. So what I'll do now is I'll demo those two different things for you, and so you can have a see whereabouts that we are. So let's go. Okay, so this is the simulation. So it's just a 2D map environment. So you've got lots of possums and lots of trees. So what we can do is create something like a fencing operation. So we can choose our contractor, select our tiles. Oops, that's not going to work for some reason. Oh well, let's do the different one then. Let's do a trapping operation. Okay, so we've got all these different things that we can put in. Let's generate that and see what happens. It's a little red dot. Let's do per hectare. Right, so that's added all these little extra red dots are traps that have been placed into the environment. Generate that, and still not okay. Why not? More contractors. That's why. Still more contractors. Crikey. Oh yeah, let's just put them all in. Okay. Let's see if we can just reduce that down again. That's okay, right. So then we have this operation where we can run it. So what we do then, we set up an operation, and basically for those, we run it over a certain amount of time. The possum groove around, move around, eat trees, fall into traps. And then we have a trap index where we caught no possums whatsoever on that one. So all those possums are out there, put all those traps out, and none of them walked into a trap. So that's kind of the dynamics of this model that we're dealing with, is we don't know what actually happens when we use it. So trying to put this into a computer game where we have clear rules and an objective can be a little tricky. So let's do something that makes a big impact on them. Okay. For those that are in the know, when you're looking at something like that, that's 1080. That's what there's the big controversial problems with 1080 use, especially on aerial drops. So we can take a look at that and see the impact that that has on possums. And on bait taken. Oh well, okay, for some reason it's obviously not working. We have possum numbers at the top, so we've got 780 possums in our little environment at this present moment. So that's the basis of that model. So let's move into the computer game. So computer game starts to visualize that environment. So I use that simulation, and I don't understand everything that comes out of that simulation. But we put this into a game. So we have, the game is running in the Unity game engine, so it's a standalone engine. It puts everything in, and we basically try and manipulate that out so we can actually get output through to Windows, Mac, and then we also hopefully can get out to iPhone and iPad as well. So we log into that one. Sound is working. So this is the basis at the moment. Is we have we have an environment set up that is a 3D environment, a spatial environment, which puts all those trees and things into context. So if we go back into here, and just like that, we create a new scenario, and that gives us our trees. So we can pop back out. We can see we've got forest, and we can see we've got possums hanging our trees. At the present moment, the art in this is all programmer art. It's just a case of having to make sure that all the functions work within the model. So we have this environment. So we can do different things at the moment. We can swing our camera out so we can see the whole environment, change the direction of that, move our camera position. But in this game at the moment, we have we can create our operations. So if we put out a fencing operation, and put a fence around there, and come back out here. Let's see if we can just zoom out a bit. Run it. Somewhere in here, a fence is being built. There it is. So we have a fence being put up into the spatial environment. So we can actually see some of the implications of what you're actually doing and how that will look in a real-world situation. So these are some of the tasks that we're going to have to achieve in the game. And then you get your feedback through from the model. So things like creating a baiting operation. Let's generate that. So we've got the little blue lines you can just about make out on here are all the different types of bait. So we start that. So have a look out here. So that's the bait being put into the environment. So over time, you'll see that the bait is put out, and then it will get eaten, and it will start to decay. So the possums will eat the bait, the possums' numbers should decrease, and so on. So it's kind of a dynamic version of that, the model that we work with. And then I have to put the whole scenario of the story and everything over the top of that. So they've taken like 1,500 kilograms of bait, which is great. And then the bait decays over time, so it still runs and decays. This is really important for the science, that things like that can be seen, so that the general public get an idea of how these work and how actually these things in the environment are affected by weather conditions and so on. Okay. And then we have things like our different types of baits and traps that people can actually look through. So at the moment, we're in the process of putting this into a much more sophisticated interface. Okay, so let's go back to... So those are where we've got to at the moment. So the story for our computer game is that the public is the hero, and they are saving the fragile but beautiful ecosystem from the jaws of the possum. The gameplay goals, you've got to save the flora and fauna. So you've got to save like kiwi birds, and you have to look after trees. You've got to repel the army of marauding possums. So by repel, that basically means you've got to get rid of them as much as you possibly can. And you've got to get your forest back to its ecosystem. The game has up to about 4+ levels. At the moment, on level 1, which is the level we're creating right now, it's all ground operations. Level 2 will be aerial operations. Level 3 is managing stakeholders. So you get to do all those kind of things, and then you have to look at different people, different landowners, community groups, government bodies, local farmers, all those kind of things you have to look and manage. So the system is going to be an adaptive system. So we're looking at being able to patch the scientific research as it comes in. So as we get new research from the game, we'll be able to patch this game and add in all the new research. So a lot of the new stuff that could be coming into the science model is bringing in rats. At the moment, we've got possums, but rats is another massive problem. So bringing in the rat dynamic into this environment means that the public can play through that. And it's a direct channel as well for public engagement with science concepts. So because we can get a fast dynamic turnaround on the iteration with kind of getting the new scientific research out there, we can actually get a feedback from what happens with the public and how they actually react to this. So our level 1, the idea for level 1 is make it more approachable, so we get it moving away from the science, is that you are creating a forest suitable for a kiwi sanctuary. So you're going to be putting a fence around the area that you've got, and you're given a kiwi egg, and you have to hatch that kiwi egg, and then you have to get it released. To do that, you have to fence the area and basically get to an epic win state of killing about 80% of those possums, all of your possums, and getting your tree health up to 80%. Then your kiwi will hatch, then you can let it go. The epic fail state is the fact that you get that the other way around. All your possums are really happy and really fed, and your trees are basically just little dry crisps. And you have an unhatched kiwi egg. So that's a really simple strategy that you can grasp straight away in such a massively complex problem. The level 1 is set in a real part of New Zealand. It's based on the land area from Boundary Stream, which is a mainland island up in Hawke's Bay. This area is controlled for possums, and it's a good area of tree recovery. So we're kind of basing a lot of that. So it's a real place you can actually go and visit. So you'll be able to walk on that part. Second part of the way I do my research is I split everything down into skill stages. So at this point, we have 5 skill stages. They move from having basic environmental monitoring, so just looking at trees and seeing how healthy they are, all the way up to applied management strategies. So using all those different tools and being able to deal with your possum numbers and keep your tree health going and monitor all those things and understand what they mean. So we build that into a nice slow learning curve, so you're not just dumped straight into the middle of the research without really knowing what it means. So this is like the 5 skill stages work towards getting your epic win, epic fail. At the moment, there's three modes of difficulty for this level. So your first level is your easy level, where you have a lot of pre-cooked operational values. So all those things we did that we're looking there, kind of like putting baits down and traps, a lot of those things are actually going to be pre-cooked. So it's fairly simple to go through those. So you can get from the beginning to the end of that level really quickly, learn the basic concepts. But then it comes out, right, if you want to try this again, you're going to just do it on a harder mode, and basically you're just going to have more things to tinker with. The 2 things that you're going to have to be dealing with, so this is the flow structure of the game at the moment. This is how we work through from our 4 operations, and then we have 2 variables. So you get to mess around with transport and people. And those are the 2 things that you can do which will affect your the constraints. And the constraints are budget and time. So you have to mess around with transport and people to keep within budget and do it in as fast a time frame as possible. So that's the premise of level 1, to work on those. The next part that we can do to increase levels of difficulty is to start unlocking things within those operations. So we can start giving you much more things to tinker with, which gives you a lot more subtlety. Don't want to do that all in one go, because it would just be too overwhelming. I mean, I don't really understand the simulation myself, but I've got to kind of figure out how we can get some of this complexity to the general public. So the idea is we really want to get to that epic win, epic fail state, but we're going to do this in that simplified fashion. So now to the fun bit. Within all this, as we can see on here, we've got this mini game. So every time you get through one of those skill stages, you unlock a mini game. This is the fun part. This has a limited bearing on the science, and it has a lot more to do with just having a good time in a game. So the mini game at the moment is being developed also as a separate standalone game that we're going to release onto iPhone and iPad, Android. So that's going to be hopefully releasing in around about maybe the end of June. We're going to do that for it's a pre-teaser sort of thing to this conference that we're going to taking the game to in London. So let me show you the mini game. So the mini game is possum stomp. So because in the main game, when you kill possums, they go into like a Ghostbusters style storage facility. So in there you have a large amount of dead possums building up. And if you get successful in that level, your storage fertility bursts, and all you get are these like lots of little zombie possums coming out, flying out into the world, and they are going to come and eat all your kiwi eggs. So you basically have to defend your nest. So this is the whole premise behind the possum stomp game. Is you get a giant kiwi, and basically it stomps on zombie possums and splats them. And this is just the basic demo at the moment. Kiwis are actually quite, they're very aggressive. There is a nice video of a kiwi stomping. It's on a real life kiwi stomping on a possum's head that came to get its nest. So yeah, at the moment this is like just our demo version. I can't finish it yet. It's just so impossibly hard, the gameplay. But we're working on it. So one of the things I'd like to kind of do with you guys when we have this game ready for playing is to give you guys a copy of it here at the lab, and you can play test it for me and get me some feedback, and then hopefully we'll get a good game out. And the idea is that the money that generates from this game, if we get sales, is going to be put towards the main research project, so we can actually carry on the research and maybe fund things. But yeah, it is a bit gory. I like it. When the possum actually, the kiwi in the new version really does stomp. It jumps in the air and stomps and stomps. Yeah, and I can never finish it. Anyway, so that's how, and then they grab eggs and then they just wander off back into the trees and sit in the trees with the eggs laughing at me. But the reason they're zombie possums is because we don't want to offend people by stomping on live possums. It's cruel, but they're already dead, so we can do what we want with them. And kiwis do defend nest, and it is a problem. Possums do predate on things like the wood pigeons, on the kiwis. They do encroach on that. They don't just eat leaves and trees. They do actually kind of eat baby birds, and they do kind of mess with nests and eggs. So it's kind of like, hopefully, it'll bring some awareness of the problem. And we've got a nice teaser. We can put a breadcrumb trail through to when we release the main game out to the public. So that's that one. So the game development at the moment, this is kind of how it's the wrong way around. How this works through. We've gone through all the pre-production. We're in production for the game at the present moment, and what we're doing is we're still searching on funding to be able to get the game up to what we're hoping for is a release, a public beta trial in around about May, so we can have open this server up to at least several thousand players who can then go in and try and break everything we've done, because not only is they've got to test the game, we've got to test the model that sits underneath it. So the dynamic science model hasn't been stress tested either. So there will be opportunity for anyone who's interested to kind of come in and play all that side of things. Our production team, this is how a serious game production team should put together. Landcare at the moment is our publisher. So they have commissioned this game. The producer of this game, project coordinator, is the lab here. And basically the research team, which is research, is me, design is me, art is me, sound, programming is Julian, for those who know Julian. Programming is like, I put that little tiny bit and he looks at me with disgust because he does far more than that. And then the QA and test, we haven't got a side of that yet, but hopefully that will open up to everyone here to kind of come and get involved in that. But we've got working with another company now to help us develop some of these side of things. Distribution of the game it's going to be distributed via web browser, so you'll just be able to play it online, log in, play it. It will provide the game when it's played on there. It will provide metrics data, so the game will log what you're doing within the game anonymously and send that back to a server, so we can create a database. So we can actually track strategies and start to see if there are any emergent patterns coming out of people's behaviour. And then from that, we can actually then use that straight back into the real-world environment. So the strategies that you play in the game might actually make it back into the real world, into kind of using for aerial drops, for trapping patterns, for all those types of things. We may find that we're getting some really good emergent behaviour from that. So that's why, really, in the end, this game is not just a game to pass on knowledge. It's a research tool. It's about getting scientific research, engagement with the public, getting metrics data, and hopefully finding some emergent behaviour that helps us provide some good pest solutions for possum management in New Zealand. Thank you very much for listening. So, oh, why did that not work? Okay, is there any questions? I don't think it recorded the screen. I'm sorry. I'm going to hit that and then it might. I'm sure I did record the screen at some point when I started. Okay, yes. Questions? Yeah.
The issue, you assume that the players will behave kind of more in a scientific manner. I found it strange because you assume like the people who play will think, then you can apply these to preserving possums. So this is one thing which is not.
I don't assume that the players will particularly use any approach. I'm just hoping that they will want to play the game because they'll want to get to release their Kiwi. And at the level 1, we're not going to really tell them it's about science and about this. It's just about the fact that you need to release a Kiwi bird. And to do that, you're going to have to go through these different operations. So it's a sneaky way of getting them into the science and the management of the environment because their goal is to have a Kiwi bird in their environment. So it's kind of quite. It's not so much about giving them the science, it's about giving them a game, and then hopefully they'll want to know what the science is behind it. So it's layering that series of information, if that helps.
Yeah. What would be the target user group? User at least the age group you would be targeting for that?
Well, it's open to anyone that wants to play it, but we're looking at an age group that spend time in front of a screen. So anyone that's kind of spending time in front of a web browser. So you're looking at, can be anything from like school kids to people who sat in offices. So it's, for the mini game, it's just getting it out there, and people like the small interactive games. So you're looking at that whole kind of 20s, 30s sort of interaction, and then hopefully getting some of the engagement with some of the more key groups. I think we're going to have to go through stealthily by getting through to maybe their kids and getting kind of them watching parents watching their kids play it and so on. Yep.
So are your plans for the game to be fundamentally like single player, or are you looking into more sort of social networking sort of stuff? Because I mean, you look at games like Farmville and stuff on Facebook, and so many people play that, and honestly it doesn't appeal to me, but there's got to be something there to drive people to do this. So.
Yeah, at this present stage we've got probably enough funding to get a single-player version of it out. But what we're hoping is, because of the data we can collect, we can actually then create a web page that will actually show some of the applications of the data and how people are actually competing against each other and how well they're doing. The mini-game will actually have the interaction, so you'll be able to compete, and you'll be able to see how many zombie possums someone's stomped compared to your set of zombie possums. So there is that there. But it's the plan would be to get it multiplayer. So what you end up with in the future is you get a piece of New Zealand, and you can play next to someone's piece of New Zealand, and you can actually interact in that environment. And your possums could cross to their possums unless you put a fence up and all those types of things. So the plan is there, but it's like then you're talking like millions of dollars, and we're doing it on less than $100,000.
About mini game, I get the idea, but to sell the app, probably there is a reason to buy the game. Not sure what the direction is, but that reminds me of the game, those zombie games. Sometimes you see this Call of Duty has some option for zombie mode. And I played those. And one thing interests me is that you have levels. Level 1, zombies coming slower, slow. Level 2, faster. Level 3, faster, more. So it's not a matter of how many zombies. Well, maybe how many zombies, but it's a matter of how many levels I have conquered.
Yeah. The minigame itself, because that's just the demo version, the minigame has 12 levels at the present moment. So you do 3 levels of 3 waves of zombies, and then you do a night mode where it all goes dark and they come at you in the dark, which is quite scary actually because they're very creepy. and then we go into, so you do that up to 12 levels of that, and then we go into like a temple run mode where you're just going into annihilating them as many as you possibly can, and that just keeps ticking up. The game also involves several different types of power-up for the mini-game. So you can have, the more zombies you kill, the more power-ups and the things you can actually do. So you can have slow mode, we've got a slow bomb mode, we've got a big stomp which kind of kills a wave of them in front of you, and then we have like the epic nuclear stomp which just boom, just knocks the whole lot out. And we have an egg retrieval power-up as well. So if you get so far and someone stole an egg, you can actually pull that back off them. So all those things are going to actually be into the mini game at the moment. So, but it's at the moment that was like the version from several weeks ago. So we've got hopefully got a new one going to be soon out.
How far are you out to making it?
I should get the game ready in. Been promised it at the beginning of May. So next week, yeah. So I'm working with some other guys because a lot of the time I'm working down with some of the guys at Stickman Studios down at the Epic site. So I'm working with them. And we're working on the games, getting those because I need more people. It can't just be me and Julian forever. It's too much. So it should be out, and then hopefully I can get versions here for people to play. And I'll have first of all one will be on the iPhone. So we'll have an iPhone version, then we're going to go up to the iPad, and then some of the Android. So it'll be a kind of tapping, and then hopefully this one as well. So yeah, I've not got a marketing plan for it yet. Yeah.
What kind of data do you collect from when the person is playing the game? It's like pretty much the whole game situation.
We can pretty much collect anything that they're doing. So it's kind of where they're clicking, what they had opened at that time, how long they were in doing one certain mode. So there's different views in the game, main games. There's like 3 different views. So we can track each camera view. We can see what, because I build everything by mission and we have mission sets, we can track a mission set and then look at all the data that was surrounding that mission set. So we can see what the behavior is on that particular strategy. Because we know what the learning outcome and what they want to achieve on a mission, say that's doing a ground-basing operation, then we can track what their strategy is for that. So we can track all of that information. It just depends. We can put it in. It depends on what Landcare want out of it. So it's just going to feed into a big pool of raw data, and then it's kind of up to Landcare what they want to mine out of that. Yeah. So yes, pretty much everything. Great. Thank you very much.